Welcome to this high-stakes explainer. Today, we are taking a seat at the ultimate table. We are going to master object-oriented programming class design specifically for your Cambridge 9618 computer science exams. Now, if you are working your way through the Cambridge syllabus, maybe you started with codes like 0417, 0478, 0983, 0984, or 2210, you know exactly how the pressure builds as you advance. It is a completely different game when you hit the A-level 9618 syllabus. It is not just about memorizing raw code anymore. It is about playing the examiner's game and winning big. You have to know when to hold, when to fold, and when to go all in on your answers. Let me paint a picture for you. We typically see two types of students taking this exam. First, we have Alex. Alex overloads every single answer with raw computer science facts, writing paragraphs of textbook definitions, but includes absolutely no analysis. Then we have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and leaves massive amounts of marks sitting right there on the table. In this explainer, we are going to fix both of those approaches. We are going to decode the examiner's mindset, uncover the hidden traps that catch students like Alex and Sam, and build a foolproof strategy so you can cash in those top marks. Let's get right into it.
Here is our blueprint for the exam. We are covering the high-stakes game first, then the house rules, followed by the methodology playbook, the specific examiner traps you need to dodge, and finally, how to play the winning hand.
Section 1. The high-stakes game. Let's look at why this specific topic is so unavoidable. The absolute, unavoidable reality of the 9618 syllabus is this. Designing appropriate classes in object-oriented programming appears in every single examination series. Let that sink in. You cannot avoid it. You cannot skip it, and just hope the examiner decides to focus on something else this year. It is going to be there. Since this challenge is a guaranteed, high-stakes feature of the test, mastering it isn't just an option. It is absolutely essential for your Cambridge computer science success. You have to walk into that exam hall knowing you are fully prepared to face it head-on. Now, before we continue and break down exactly how to do that, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the strategy.
That brings us to a really fascinating question, and it is one that principal examiners are constantly asking in their reports. Why do students find evaluating algorithm efficiency and designing these OOP classes so incredibly hard? It is a high-stakes question. Let's think back to our two students, Alex and Sam. When Alex looks at an OOP question, they just see an opportunity to dump every single fact they know about inheritance, polymorphism, and encapsulation. They write a massive wall of text. But because they do not evaluate the efficiency of the specific algorithm or class design requested by the prompt, they get almost 0 marks for analysis. Sam, on the other hand, looks at the same question, panics about the time, sees the word class, writes a quick generic class structure, and completely ignores the command word that says evaluate or justify. Understanding why Alex and Sam fail is exactly how we learn to beat the house. They fail because they don't understand what the examiner is actually scoring. Let's look at the house rules to figure out what that is.
Section 2. The house rules. The core principles of the exam.
If you want to win, you have to know what the Cambridge examiners actually value in your answers. Listen to this direct quote from a recent principal examiner report. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. They want the why behind the code, not just the how. They are testing your ability to take a theoretical architecture and apply it to a completely new scenario you have never seen before. To do this, top students use something we call the PEAL framework. That stands for point, evidence, explanation, link. When you are asked to design an appropriate class, you don't just write code. You make a point about why a specific class structure is best. You provide evidence from the scenario. You provide an explanation of how your code solves the problem. And finally, you link it back to the specific command word in the question. This PEAL framework is the absolute best way to show that connected, conceptual understanding the examiners are literally begging for.
The ultimate difference between an average, middle-of-the-pack answer and a top-tier answer comes down to isolated facts versus cross-topic connections.
The data from the principal examiner reports is crystal clear on this. Candidates who integrate cross-topic connections, meaning they seamlessly link OOP class design to other syllabus areas like data representation or file processing, achieve significantly higher marks. Think about ALEKS again. ALEKS relies on isolated facts, just a list of definitions. If you do that, you are folding your hand early. You need to show the examiner exactly how all the pieces of the computer science puzzle fit together to solve the specific problem they handed you.
Section 3. The Methodology Playbook. Let's get into the tactical side of things.
Let's look at how to secure guaranteed payouts through what I call the method mark strategy. In object-oriented programming and algorithm problem-solving, marks are often awarded for the process itself, not just a perfect final answer. This table brilliantly illustrates how you map your algorithmic actions directly to evaluative outcomes. For example, if you extract data from binary representations, you are proving to the examiner that you can identify given information. When you perform calculations or manipulate arrays within your OOP class, you are showing you can systematically solve a problem. And crucially, when you draw evidence-based conclusions about why your class structure is the most efficient, you are making justified recommendations. This is exactly where the Peel framework saves you. By showing your analytical process on the page step by step, you are claiming method marks. Even if your final code has a minor syntax error or you forget a semicolon, the examiner sees your logic and awards you the chips.
Building directly on that, this procedural framework lays out a logical map for your algorithmic thinking. Think of this as your personal transformation from a 0-mark answer to a full-mark answer. Step 1, decompose the problem step by step. Step 2, select the appropriate data structure. Step 3, implement efficient code. And Step 4, test rigorously. Let's imagine you have 60 seconds to rewrite one of Sam's rushed answers. If you follow this exact sequence when designing your classes, you are basically accumulating points at every single step. It takes a massive, intimidating exam prompt and breaks it down into manageable point-scoring actions. You aren't just staring at a blank page anymore. You are executing a strategic blueprint.
Section 4. Avoiding examiner traps. Before we expose exactly where past candidates lost their chips, I have an important message. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at those traps. The examiners have told us exactly where past candidates went wrong. These are the top 3 classic mistakes pulled straight from the reports. First, confusing cause and effect within object-oriented relationships. For instance, getting mixed up about how a change in a parent class affects a child class. Second, forgetting to check boundary conditions and edge cases. This is a massive one. If your class design does not account for what happens at the absolute extreme limits of your data, like when an array is entirely full or completely empty, your logic is incomplete and you lose marks. And third, the absolute most lethal mistake of all, providing generic answers that are not specific to the question context. This is the trap Sam falls into every single time. Sam rushes, misses the context, and writes code that could belong to any program in the world, not the specific scenario the examiner created. You must avoid these 3 traps at all costs.
So how do you remember to check for all these things under intense exam pressure? You employ a memory hack known as the visual story method. Let's do a quick data scan challenge right now. Imagine a complex computer science data structure like a queue for a printer spooler. You have to visually encode the abstract OOP concepts and those easily forgotten boundary conditions into a mental narrative. Imagine the objects in your program interacting like real characters in a physical room. Visualize what happens to them when they hit the literal edge of their environment, like the room filling up with too many people. That is your boundary condition. This method makes it significantly easier to securely encode complex relationships in your memory and recall them instantly when you only have 60 seconds left on the clock to figure out a core trend.
Section 5. The winning hand. This is the evaluation strategy that brings it all home. Let's play a game of Find the Flaw. Remember that third trap we just talked about? Generic answers lose marks, while context-specific answers get top marks. Imagine a sample paragraph that says, "Encapsulation is used to hide data and keep the variables secure within the class." Can you spot the flaw? The examiner commentary would rip that apart because it is entirely generic. You cannot write a textbook definition of encapsulation and expect full credit. You must always link every single point and technical decision directly to the given scenario. If the question is about a hospital database system, your classes, your private variables, and your evaluation must specifically reference patients, doctor IDs, and appointment times. If you don't anchor your answer to the context, you are throwing your chips away. Context is quite literally everything in the 9618 exam.
To truly demonstrate evaluative thinking, your answer needs to hit these 4 exact bullet points. This is where speed writing practice comes in. Imagine you have 30 seconds to write one perfect Peel paragraph. You need to consider multiple solutions, analyze the trade-offs between them, acknowledge the limitations of your chosen design, and justify your decisions with clear evidence. Top-scoring candidates do this beautifully by using comparative connectives. They use phrases like however, whereas, and in contrast to show similarities and differences. They do not just state that one OOP approach is better. They prove it with solid, evidence-based reasoning, following that point, evidence, explanation, link structure flawlessly.
Let's tie this entire system together with the ultimate problem-solving algorithm. Step 1. Deconstruct. Identify the given information, decode those tricky command words, and break the scenario into logical steps. Step 2. Solve. Systematically build your OOP classes, remembering to apply the Peel framework to your written explanations. Step 3. Evaluate. Check your boundary conditions, test for reasonableness, and make those justified context-specific recommendations we just discussed. If you implement this 3-rule system involving command word decoding, the Peel framework application, and strict time management, you are executing the perfect deconstruct, solve, and evaluate strategy.
So here is my final question for you. Are you ready to apply the MethodMark strategy and claim your high-stakes OOP chips? Students who implement these exact computer science strategies see an average improvement of 2 whole grade boundaries. But that only happens if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to Ace the Exams_IGCS and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for computer science and the biggest challenge you're currently facing with OOP. Our team actually responds to every single comment. Make sure to like and share this explainer with a study partner so you can hold each other accountable. Ace the Exams, your Cambridge success starts here. Keep practicing, focus on the process, and you'll do absolutely great.